In this problem, we are asked to find the antiderivative of the cosine of log of x. Thank you for viewing this video. Please like the video and subscribe to our channel, this will help the growth of our channel. When we look carefully at the function cosine of log of x, the first thing that comes in mind is that this function is a composition of two functions, the cosine function and the logarithmic function. This suggests that we should first start with the u substitution method. It is evident that the natural choice for the parameter u should be the inner function. Thus, u should be log of x. We set u equal to log of x, then du equal to the fraction 1 over x, and more importantly we note that x equal to exponential of u. The integral of cosine of log of x dx can be expressed as the integral of x times cosine of log of x times 1 over x dx. We can clearly see u and du in the expression of the integral. So, we replace log of x by u and 1 over x dx by du and obtain the new expression of this integral as the integral of x times cosine of u du. This suggests that we have to replace x by its expression in terms of u. But we know that x is exponential of u, therefore we have the new expression as the integral of exponential of u times cosine of u du. In order to compute the integral of exponential of u times cosine of u du, we have to use the integration by part method. Recall the integration by part method. In this new approach, we set v equal to cosine of u and dw equals exponential of u. Thus, dv equals negative sine of u and w equals exponential of u. Therefore, the integral of exponential of u times cosine of u du is equal to exponential of u times cosine of u plus the integral of exponential of u times sine of u du. We see that we still have to simplify the integral of exponential of u times sine of u du. We still use the integral by part again to simplify this integral. Once more, we set v equal to sine of u and dw equal to exponential of u. Thus dvi equal to cosine of u and w is equal to exponential of u. The integral of exponential of u times sine of u du is then equal to exponential of u sine of minus the integral of exponential of u times cosine of u du. We then combine equation 1 and equation 2 and we see that the integral of exponential of u times cosine of u du appears on both sides of the new equation. We move those terms on one side. When we solve the resulting equation, we see that the integral of exponential of u times cosine of u du is equal to 1/2 times exponential of u times the sum of cosine and sine of u, plus the constant c. In sum, the integral of cosine of log of x is equal to the integral of exponential of u times cosine of u du, which is equal to 1/2 times exponential of u times the sum of cosine and sine of u. When we replace u by log of x, we have the final expression of the antiderivative as 1/2 times x times the sum of cosine of log of x and sine of log of x, plus the constant c. Thank you for viewing this video. Please subscribe to our channel. We have an extensive collection of calculus-related videos covering limits, derivatives, integration, and many other calculus topics.